right, 12.1b, constructing a confidence interval for the slope. So anytime you do a confidence interval, it's the statistic plus or minus the critical value, which is either t star or z star, times the standard deviation of the statistic. So for our statistic here, we're talking about the slope and the standard deviation of the slope. So don't forget, yesterday we talked about liners. Those are the conditions that you're going to check. So linear, independent, normal, equal standard deviations, and random. And then we can go ahead and construct a confidence interval. So here's the formula you want to write down. Little b is the sample slope. We're using that to predict the population slope. T star, you can do inverse T on your calculator. Area is whatever area you're doing for 95%, 90%. And then degrees of freedom is different. Be sure you write this down. It is n minus 2. And then we've got SEB. This is standard error of the slope. So pay attention that you're finding standard error of the slope. The formula for this is right here. We don't really use this formula. It's going to be given to you most of the time, or actually all the time. However, you do need to interpret it. So this is standard error of the slope, and you want to be sure you write this down. It estimates how much the slope of the sample regression line typically varies from the slope of the population or true regression line if we repeat the data production process many times. All right, so it's how much the slope varies from the population regression line. All right, so we've got our helicopter experiment. We dropped 70 helicopters, and we're looking at their flight times compared to how high we dropped the helicopters from. So you need to be able to read Minitab. So our constant, this is our A, which is our y-intercept right here. Okay, so be sure you know this is the y-intercept. We did this in chapter 3. And this is B. This is our slope. Okay. And the other important piece for confidence intervals is this one right here. So notice this is all slope going across. This is also slope. And then I have SE, which is standard error. So this one's standard error of the y-intercept. This one is standard error of the slope. This is the one we're going to use right here, which is SEB. So give the standard error SEB and interpret it in context. So here is our standard error, and we need to interpret it. You might want to write this down so you can practice interpreting it. So if we repeat the random assignment many times, the slope of the sample regression line would typically vary by about 0.0002 from the slope of the true regression line for predicting flight time from drop height. So be sure you say what you're predicting, all right? So you repeat the process many times, and again, we're doing the slope of the sample regression line. That's how much it's off from the slope of the true regression line. All right, part B. Find the critical value for a 95% confidence interval for slope of the true regression line and go ahead and calculate the confidence interval. So this is not the 4-step process. We're just doing the confidence interval right here. So here's our formula for confidence interval, and we're going to use Minitab to plug it in. So I'm looking for little b. So here's the slope of our sample regression line, 0.0057. Plus or minus. Okay, T star is inverse T on the calculator. And we're looking for an area. We're doing 95% confident, so half of 5% is 0.025. And then we're doing degrees of freedom is n minus 2. So n is 70. We dropped 70 helicopters. And so n minus 2 is 68. You must list degrees of freedom here. All right. So once you plug that in, you get 1.995 for T star. And then we're going to multiply by SEB. This is the one that people tend to mess up the most. So be sure you know where to find this. 0.0002. All right, plug this in, add and subtract. Don't forget, you guys, this whole thing is the margin of error. If it asks for margin of error, you're looking for this times this, how much you added and subtracted to the sample slope, okay? All right, so we're going to get a confidence interval of 0.005 to 0.006. Okay. And then part C, interpret the interval. So we've done this a million times. We're 95% confident that the interval from 0.005 to 0.006, this part's important, units. We're talking about seconds per centimeter here for our slope, time over how far we dropped it. So this captures the slope of the true regression line relating the flight time y and the drop height x of paper helicopters. Again, be sure you say what you're relating in context, okay? And we haven't done this one in a while, so explain the meaning of 95% confident. So this goes with this definition you wrote down a long time ago when we did chapter 3. I am blank percent confident that the interval from blank to blank captures the true whatever we're talking about, okay? If we repeat the process many times. Actually, that's the one for this one. So this one, sorry, ignore. We already did this one. So you guys, if we repeat the process many times and use the method in part B to construct a confidence interval each time, so this is confidence level, about 95% of the resulting confidence intervals will capture the slope of the true regression line relating flight time y and drop height x of paper helicopters. All right, so that's confidence level. This is just interpreting it like we did in part C, which is what you normally do. Okay, so let's do a whole confidence interval for our truck problem. So we've got miles driven versus price, and we looked at 16 trucks on autotrader.com. Okay, here's the Minitab output. They gave it to us. We have a scatter plot here. We have our residual plot with no leftover pattern. And we've got our histogram of the residuals. Okay, or a normal probability plot here of the residuals would also work. And then we have our Minitab output, and we're going to construct and interpret a 90% confidence interval for the slope of the population regression line. So state, we want to estimate the slope, capital B, of the population regression line relating miles driven to price with 90% confidence. All right. And our plan, this is called a t-interval for slope. So you may want to write that down, the name of the test, t-interval for slope. And liner stands for what? So L is, okay, linear. So we're going to look at these two things. We've got our scatter plot is roughly linear, and our residual plot has no leftover pattern, so we can assume it's linear. Another way they say this is the residual plot shows random scatter about the residual equals 0 line. All right, and I in liner is independent. So did we sample with replacement or without replacement? And then we do the 10% rule. So when we're picking out a truck, we're not replacing it into the data. So we need to check 10% rule. We've got 16 trucks, which means we need at least 160 trucks in the sample. So we can assume that there's 160 trucks listed on autotrader.com. N stands for normal. Is it normal? So you want to look at the histogram of the residuals or the normal probability plot of the residuals. So they're going to say that this is roughly symmetric and we're good to go. So histogram of residuals is roughly symmetric and single peak. There are no obvious departures from normality. All right, E stands for equal standard deviations. So that's where we want to look at this residual plot and see how far away the points are. And we need to have roughly the same above and below. So remember it was a problem if, I should have done different color, but anyways, it spread further as you went across. So if your standard deviations kind of increased or something, then you have a problem. But since we have random scatter, we have equal standard deviations, so we're good to go. And you may want to write this down for how they say this. So the scatter plot of points around the residual equals 0 line appears to be about the same at all x values. Okay, and then random, we have randomly selected 16 trucks, so we're good to go. All right, so now we're going to actually do the confidence interval. So little b, okay, which number is the slope of the regression line? All right, so I have negative 0.163. or minus, and now we do inverse t on our calculator. And this time we're doing a 90% confidence interval, I believe. Yep. So we put in 0.05. And degrees of freedom is always n minus 2. We had 16 trucks, so 14. And for T star, we get 1.761. All right, times SEB. So be sure you know where to find SEB. So here's my slope part here. Here's SE. So we're looking for 0.031. Okay, plug this in, and we're going to get a confidence interval of negative 0.217 and negative 0.108. And our conclusion, we're 90% confident that the interval from this to this captures the slope of the population regression line relating price to miles driven for all Ford F-150s. Okay. So this guy right here is alpha, that's how we say it, and this represents true y-intercept. Okay, this A like this is the sample one. Okay, sample y-intercept. Beta, this is the true slope, and then our B is the sample slope. All right, and then we've got sigma. Oh, yeah, this is beta, and this is sigma. Sigma is the true standard deviation. All right, we use SEB a lot for standard error of slope. So be sure you know the difference there. Oops, standard error of slope. All right, so on your calculator, you guys, you go to menu, stats, confidence intervals, and we have a new one here, linear regression t interval. So if you plug in, here's our truck problem, miles and price. You can do it from this page or your calculator page. Go to menu, statistics, confidence intervals, and this one right here, number 7, linear regression t intervals. So there's two things you can find, slope and response variable. We're going to do slope. X list is miles, Y list is price, and we were doing a 90% confidence interval. There we go. All right, so we've got y equals a plus bx for our equation. Here's our upper and lower bounds for our confidence interval. Here's b, so the slope of the sample. Margin of error is the t star times the standard error of b. Degrees of freedom is 14. Be sure you write that down in your problem. And SEB, this is the one you're looking for, you guys, standard error of the slope. And some other stuff we talked about in chapter 3. All right, guys, this is the one that I meant to say for confidence level. So if the random sampling or random assignment were repeated many times about whatever your confidence level is, that percent of the resulting confidence intervals would contain the true, and in this case, slope. Okay? So this is the one that goes with explain the meaning of 95% confident in context that we did here. All right? So those sentences you should have from chapter 3, but if you forgot, you may want to write them down.